Welcome to another instructional video from OWL, the wise choice in fiber optic test equipment. I'm Professor Jim Powers. This video will help demonstrate how to check your Zoom 2 optical power meter for proper operation using a dual OWL multimode light source.
It is always a good idea to check your patch cables and test equipment prior to testing for the day. Usually at the beginning of the day is a good time to check your patch cables and equipment to ensure accurate and reliable test results. Now in this procedure we will be using the Zoom 2 optical power meter and the dual OWL multimode light source. Now you will see that there are 3 patch cables and 1 mating sleeve used in this procedure. Okay, these 2 cables right here are going to be used to connect the dual OWL to the link under test when we're actually performing the test. You'll see that they are wrapped around a mandrel per cabling standards, and the reason I have 2 of them is because there's 2 wavelengths that we could use for testing. Now this 3rd patch cable is used to connect the Zoom 2 into the link under test when we're actually doing the test. And the mating sleeve here is used during this procedure only. It'll probably not have to be used during the test actually. So now to ensure that the test cables will work with the link that you're testing, you have to make sure that they have the right connector types, that they don't have to match. They can be different from the connector types on the test equipment, but for this example we are going to assume that everything is SC from the test equipment to the patch panels. Now to test these cables, first we need to connect the reference cables to the dual OWL. So we'll do that now. Okay, and we can power on the units whenever we want to, so we might as well do that now. On the Zoom 2, you can press the power button here, and on the dual OWL, press the power button here. And notice that the indicator LED is lit by default for the 850 nanometer wavelength. Also, with the Zoom 2, notice that the reading says low. Okay, what this means is that there's no light coming into the photodetector. That's because there's a dust cap on the detector right now. You'll notice if I disconnect this, there will be a reading there. What's happening here is that the meter is now measuring ambient room light. This is normal, so don't worry. This is fine. So what a power meter does, it measures all of the incoming light that's coming into the photodetector. Okay, now to check the patch cables here, we need to connect them into the Zoom just to check our reference levels. So we plug in one of these duplex cables, and again you'll see that we have low. That means that we probably have the wrong cable on the duplex cable assembly here. That's very common. All you have to do is disconnect. Put the dust caps on. It's always a good idea to do that. And we plug in the other side of the duplex cable. Okay. Now, the reading we see on the screen is what we would consider our reference level. Our target value is approximately -20 dBm. You'll see that there's a dBm over here. We need to make sure we have that set. But we're looking for -20. So -20.25. That's very close. This is actually a good reference cable. So once we've checked the 850 nanometer cable, we can disconnect it and put the dust cap back on. And then we plug in the 1300 nanometer cable. Again, we see low, probably because we haven't switched the wavelength on the light source yet. Okay. Now, to test the 1300 patch cable, we need to switch both units to 1300. On the dual OWL, just press the wavelength button here. You'll see that the wavelength switches over to the right-hand side, and then on the Zoom, we press the power or the lambda button, and we'll see that it changes to 1300. Now, we see a reading that's -19.55. Okay, it's a little bit higher than -20, but this is acceptable. As long as we don't go below -21 dBm, then we can be assured that our patch cables are fine. Okay, so we know that both of our reference cables are fine, so now we need to check this straight cable here. The easiest way to do that is to first temporarily zero out this 1300 nanometer wavelength. We can do that by pressing and holding this 0 button. Okay, now we see that we have a reference level there. It's reading roughly 0.0. That's very close to the reference level. That's why we call it zeroing. Notice that the unit also switched to dB. dB is the mode that you use to measure loss in. Okay, once we've zeroed out this patch cable here, now we connect in the straight cable via this mating sleeve. So we just plug the mating sleeve on the end of the reference cable. We plug one of the ends of the straight cable into the adapter, and then we take the other end of this straight cable and plug it right into the detector port on the zoom. Okay, notice that we have a reading of 0 dB. Okay, what this means is that we're reading right at our reference level. What really means is that the straight cable here and this adapter are introducing absolutely no loss into the link. This means that this cable is also good. Now it could be a quarter dB and it would still be okay, because usually there's a little bit of loss in a mating sleeve like this. So what we've done now, we've assured that all of our patch cables are working correctly, and now we can proceed with our insertion loss measurement.
If the power level falls below the acceptable power level range, debris such as dust, dirt, or finger oil may have collected on the connector end face or in the equipment's optical ports. Thoroughly clean and inspect all connector end faces and equipment's optical ports according to industry standard cleaning procedures. Several cleaning cycles may be required. Keeping connectors and optical ports clean at all times helps to keep test equipment in good working order and proper calibration, ensuring accurate and reliable test results. When not in use, dust caps should be kept on fiber connectors and optical ports to keep debris from collecting on the surfaces of the connectors and ports. During testing, it is highly recommended to clean and inspect both connectors and optical ports every time a connection is made. Failure to properly maintain your test equipment could needlessly result in costly repairs. For example, over time, repeated connector insertions into a dirty optical port could grind the debris into the optics in an equipment port. This type of damage is permanent and cannot be repaired in the field. If the problem still exists after thorough cleaning and inspection, the patch cable may need to be replaced. Patch cables are typically rated for a few hundred connector insertions, but can prematurely wear out or become damaged if they are not properly handled and maintained. If the power level is still too low, even after patch cable replacement, contact OWL Technical Support for assistance. This has been another instructional video from OWL, the wise choice in fiber optic test equipment. For more information about additional instructional videos or OWL fiber optic test equipment in general, please visit OWL's website at owl-inc.com. I'm Professor Jim Powers. Thanks for watching.